Hello OT learners, and welcome to today's video where we will be looking at alternating current practical examples. So without wasting much time, let's hop into this. So example number 1. A high voltage power line operates at 500,000 root mean square voltage and carries a root mean square current of 500 amperes. If the resistance of the cable is 0.050 ohms per kilometer, what is the resistive power loss in a 200 kilometer of the power line? So let's look at the solution. So solution. So first of all, let's try to know the parameters that we have in this question. So we have a high voltage power line operates at 500,000 root mean square voltage. So it means our root mean square voltage that we have been given is what? 500,000. Okay, volts. Then we have a root mean square current of what? 500 amperes. So our root mean square current, okay, is 500 amperes. Then we have the resistance, which is R. Okay, so let me clean this. So the resistance per kilometer is what? 0.050 ohms. Okay, so we've been asked to find the resistive power loss in a 200 kilometer, okay, power line. So let's look at what we have. We know from alternating current that power is equal to what? Voltage times current. Now in AC theory, our voltage is not just any voltage, but it is what? A root mean square voltage. And our current is not just any current, but a root mean square current. Resistance still remains resistance, and depending on the component that you have, the resistance may change to what? Impedance, okay, which is the overall resistance if we have a capacitor or a resistor or an inductor inside, but that will be for another tutorial. So we have power is equal to what? Voltage times current. But we know from Ohm's law that voltage is equal to what? IR, which is what? Current times resistance. Okay, so what it means is that if we use this as our equation 1 and this is our equation 0, if we substitute this into this, we get power is equal to what? Voltage, which is now IR, multiplied by another I. So in the end we are getting what? I square R as our formula for power. Okay, so which means our power loss in this case will be equal to what? The square of the root mean square current multiplied by the resistance of the power line. Now let's look at something. We have here the resistance, okay, is what? 0.050 ohms per kilometer. Okay, so we can go ahead and substitute our current, which is 500 here. We square it and we multiply it by the resistance, which is this guy, and we get the answer. But that will be wrong in the sense that per every kilometer the resistance in the power line is 0.050, but we've been given, the question is asking us to find the resistive power loss in a 200 kilometer power line, not just 1 kilometer power line. So we need to find the overall resistance in the 200 kilometer power line before we can be able to do the substitution. I hope you understand. Alright, so if we do, let's try to find that. So for this we use basic ratio to find the overall resistance. So we say that if 1 kilometer power line has the resistance of 0.050, then a 200 kilometer power line should have, let's say, X, okay, ohms of resistance. So here we cross multiply. So if we do that, we have S ohms kilometer because x times 1 will give us x, is equal to 200 multiplied by what? 0.050, and the unit is what? Ohm, multiplied by what? Kilometer over here. Okay, now we get to realize that we are looking for what? Resistance in ohms, so the kilometers will cancel each other. So our x, okay, in ohms will be what? 200 multiplied by 0.05, and if we punch that into our calculator, we are going to get what? 10 ohms. So it means our overall resistance, okay, in the 200 kilometer power line is what? 10 ohms. So now that we have the overall resistance, we can simply do the substitution and get our what? Resistive power loss in this 200 kilometer power line. So our power loss now will now become, our root mean square current is what? 500. So we have 500 squared multiplied by 10. Okay, now if we do the multiplication really well, okay, if we multiply this by this, 500 squared multiplied by 10 will give us what? 2,500,000, okay, watts of power. Okay, so we can convert this into a more friendly way of writing. So if we want to convert it into megawatts, okay, 2,500,000 watts will give us what? 2.5 megawatts. So this becomes 2.5 megawatts as our overall resistive power loss in this 200 kilometer power line. Let's go ahead and look at the second example that we have. Alright, so we have a 10 microfarad capacitor is plugged into a 110 root mean square voltage source, 60 hertz voltage. Let me take that again. A 10 microfarad capacitor is plugged into a 110 root mean square voltage, 60 hertz voltage source, okay, with an ammeter in series. What is the root mean square value of the current through the capacitor? So let's write down our solution. Alright, let's look at the parameters that we have. So we've been given the capacitance of the capacitor to be what? 10 microfarad, which is equal to what? 10 times 10 raised to the power what? Minus 6 farad. Okay, we've been given the root mean square voltage, of the circuit to be 110 volts. We've also been given frequency to be what? 60 hertz over here, and we've been told that the ammeter and then the capacitor are in series. Okay, and so we have to find the root mean square current of this particular circuit. Okay, so the root mean square current is what we don't know. Now in a capacitive circuit, that is a circuit that we have a capacitor as our main source of opposition to the flow of current, our resistance, which we call capacitive resistance, is given by the formula SC, okay, which stands for what? Capacitive resistance to be what? 1 over 2 pi fc, where the C over here is the capacitance of the capacitor. I'll take that again. In a capacitive circuit where we have a capacitor and then an ammeter and then a power source, okay, the opposition to the flow of current in this circuit is what we call capacitive what? Capacitive resistance, okay, represented by XC, and it is given by the formula 1 over 2 pi fc, where the C is our capacitance of the capacitor and F is the frequency in the system. Okay, now for us to be able to find the root mean square current, we need to write the formula, okay, for this. So we know Ohm's law, which is what? V is equal to what? IR, when we are dealing with what? Direct current. But in an alternating current, our voltage here becomes our root mean square voltage, our current becomes our root mean square current, our resistance, okay, because we are dealing with a capacitor in this case, becomes what? Our capacitive resistance, this SC. So this becomes our capacitive resistance. Okay, now, so for us to be able to find the root mean square current, it means we need to find a capacitive resistance for the circuit. So let's find that first. So our XC becomes 1 over 2 pi. The F, which is the frequency, is 60, and then the capacitance of the capacitor, okay, is 10 multiplied by 10 raised to the power negative 6. So our capacitive resistance, okay, if we compute everything over here into our calculator, we are going to get 265.26 ohms. Okay, so this is our capacitive resistance. Now that we have our capacitive resistance, we can do the substitution to find our root mean square voltage. So let's do that. So our root mean square voltage is equal to our root mean square current multiplied by the capacitive resistance. So to find the root mean square current, we have the ratio of what? The root mean square voltage on the capacitor. So our root mean square current is equal to, the root mean square voltage is 110 volts on our capacitive resistance is what? 265.26. so our root mean square current in this case will be what? 110 on 265.26, and this is going to give us a current of what? 0.415 amperes. So for this example, our root mean square current is 0.415. Now let's look at another final example. A 0.5 Henry is connected into a 110 60 Hz voltage source with an ammeter in series. What is the root mean square value of the current through the inductor? So let's have a look at the solution for this problem. So we write down our solution. First of all, let's list the parameters that we have. So the inductance of the inductor over here, okay, is 0.5 Henry. Our voltage, which is the root mean square voltage, has been given to be 110 volts. We've been given frequency to be 60 Hz. Okay, and we've been asked to find the root mean square current, okay, through this inductive circuit. Now, in an AC theory containing an inductor, okay, using Ohm's law, our voltage becomes, which is the root mean square voltage, becomes what? Our current, which is root mean square current, multiplied by our resistance. Our resistance in this inductive circuit becomes our what? Inductive resistance, which is what? XL. Okay, so first of all, before we find our root mean square current, we need to find our inductive resistance. Now, inductive resistance XL is giving us 2 pi FL, where L is the inductance of the what? Inductor, and then F is the frequency in the circuit. So let's calculate our inductive resistance. So we have 2 pi, the frequency is 60, the inductance is 0.5. okay, so 0.5 multiplied by 60, that becomes 30, multiplied by 2 pi, that gives us our inductive resistance to be what? 188.50 ohms. Alright, so for us to find our root mean square current, we will get a ratio from here. If we divide all by XL, we get our root mean square current to be what? The root mean square voltage on the inductive resistance. So our root mean square current over here is what? Our root mean square voltage on our inductive resistance. So this becomes 110 on 188.50 and this gives us a current of what? 0.584 amperes as our root mean square voltage. So this is how we solve some practical examples on an AC theory containing an inductor and capacitor, as we saw in the first example, and then in the second example, and resistance in the first example. So thank you so much for watching. This is actually my first tutorial as the online tutor on YouTube. Now the online tutor, the abbreviation is OT. So I'm preparing lessons that I call the OT lessons on my Instagram page. So if you want to become an OT learner, which is just part of the community of the online tutor, which is me as the online tutor, and you want to join me and take part in my OT lessons, make sure to follow me on IG, which is Instagram, at the online tutor 990.